Welcome to the deep dive where we unpack the complex to make you truly well informed. Today, we're zeroing in on a really fast moving area in AI agents. I mean, we've seen this striking figure, something like a 254% increase in companies calling themselves agentic getting into Y Combinator just over the last 3 years.
Well, it's a huge signal, right? Big investment, lots of buzz. Definitely demands our attention. So our mission for this deep dive is to give you the clearest picture we can. What does it really take to build effective applications with these AI agents? We want to move past the hype, get into the practical side of things. And our insights today, they're coming straight from someone deep in the trenches. Michael Albada, he's a principal applied scientist at Microsoft. He's been right at the heart of things like Security Copilot, the Security Copilot agents, background at Uber too. And he's basically distilling down insights from, get this, a 300-page book he's got coming out on this. So yeah, get ready. We're going to unpack the promise, which is huge, but also let's be honest, the very real obstacles in agentic development.
We'll dig into the core components you actually need for systems that are ready for production and uncover some common pitfalls, lessons learned the hard way, probably. This deep dive should give you some really practical insights, maybe even some surprising facts to help you navigate this whole new frontier. Okay, so let's unpack this then. There's just so much excitement, right? And all this investment swirling around AI agents. What's really driving it all?
It's absolutely palpable, you're right. And look, for good reason in many ways. What's fascinating, though, is when you look at the leading agentic benchmarks coming out of academia, the performance is impressive. I mean, we're seeing scores in the 50s, 60s, even 70s on tasks where maybe 5 or 10 years back, we were stuck in single digits.
Yeah.
So huge progress.
Okay, so definite improvement.
Definitely. But, and this is important, we really need to temper expectations. These are fundamentally hard tasks. They often require, a sequence of multiple tool calls, these sequential executions, operating in pretty complex environments. It turns out it's relatively speaking, easy to get to that first, say, 70% accuracy.
Right.
But that long tail of increasingly complex, nuanced scenarios, that's where the real challenge bites. Think of it like trying to perfectly land a jumbo jet. You might get it 70% of the way to the runway smoothly. But that last part, that's always the trickiest. You definitely shouldn't expect perfection right out of the gate.
That's a really crucial distinction. So, okay, maybe we should back up a step. What exactly is an AI agent? Like, what makes a system agentic compared to just, smart software?
Yeah, good question. At its core, you can think of an AI agent as an entity that can reason, act, communicate, and adapt, all in service of solving tasks. You typically start with a foundation model. That's the base layer. And then you add these additional components on top to boost its performance, its effectiveness in different situations. But it's really important to grasp that agenticness, it's not like an on-off switch. It's not binary.
Right.
It's more of a continuum. And there's this second equally critical axis, effectiveness.
Right.
How well does it actually do the job? Because agency in itself, it's really just a tool to help you solve problems. It's not the end goal.
That clarifies it perfectly. So it's not just raw intelligence, it's about delivery, how well it performs in the real world. It kind of reminds me actually of RPA, robotic process automation. Businesses have used that for ages, right? But you wouldn't really call those systems agentic?
Precisely. RPA is like a classic example. Very low on the agency scale, right? But really high in efficacy. It gets the specific job done.
Yeah, very reliable for specific things.
Exactly. It's useful, delivers economic value, no doubt. But it's fixed. It's brittle.
Yeah.
You make small changes to the input, the format, whatever, and bam, the whole thing can break. Needs lots of manual tweaking, manual intervention.
Right. Constantly needing updates.
Yeah. So the promise of these more agentic systems is that flexibility, that adaptability. They can potentially handle those changing inputs much better. Yeah. But the key, the absolute key, is making sure that as you dial up the agency, you maintain that high level of effectiveness. What we absolutely want to steer clear of are, well, bad chatbots. Low efficacy, low agency, just frustrating.
Definitely want to avoid those.
But we also need to avoid sort of going out over our skis, building these super complex, highly agentic systems that, in the end, just don't work reliably. Low efficacy again. Frankly, those are kind of future news stories that, well, none of us want to be involved in creating.
That's a really powerful way to put it. So what's the hardest part then? Maintaining that high efficacy while you're trying to make it more agentic, more flexible. Where do teams tend to stumble?
I'd say the biggest struggle often comes back to that long tail we talked about. Just the sheer, almost infinite variety of edge cases and unexpected inputs that can chip away at efficacy if you haven't planned for them. And a super common misstep. Underinvesting in really robust evaluation early on, there's this temptation to think the foundation model will just kind of magically figure it out.
Right, just throw data at it.
Yeah. And that rarely works
Sure.
for complex real-world tasks.
Mhm.
You need that structure.
Okay, let's pivot then. Let's get practical. How do we actually build these effective agents? Tool use seems absolutely fundamental here.
Tool use is.
Yeah.
It's incredibly powerful. And it's based on a deceptively simple idea, actually. Foundation models, right? They're these autoregressive generative models. They predict the next token, usually natural language. But, and this is the crucial bit, they can also be trained or prompted to output things that look like function calls, code snippets, essentially. So if you expose your tools, your functionalities through APIs, the agent can effectively learn to call those functions. Think about the massive range of functionality this suddenly unlocks. You can connect the LLM to almost anything.
Huge potential.
Huge potential. But also inherent risk, right? You have to be really discerning, really responsible about which functionalities you expose and how you expose them. The process generally works in a loop. The agent gets a prompt, generates an output that includes the function call, you apply a parser to extract that call, invoke the actual tool.
Ooh, okay.
The tool runs, returns some result or observation. That observation feeds back into the agent as more information, and this loop continues until it generates like a final answer for the user.
Got it. That loop makes sense. Now, with this power of tool use, what's the biggest temptation? Or maybe a common pitfall you see developers falling into when they first start hooking things up? Is there a too much of a good thing scenario?
Oh, absolutely. And here's a critical insight, one that's maybe a bit counterintuitive, that lots of teams miss initially. More tools does not automatically mean better performance.
Really? You'd think more options would be better.
You would think, but we've actually seen empirically through testing that the more tools you expose to an individual prompt, like in a single completion call, the less accuracy you often get.
Why is that?
It seems to be due to increased semantic collision. Basically, the model gets confused. It struggles to accurately differentiate between too many options, especially if they sound similar or overlap in function.
Okay, that's fascinating.
So the key takeaway, the advice I always give, drastically reduce the number of tools exposed at any single point in the process. Group them logically. Give them really specific, clear names and descriptions. Make sure each tool feels like a single, distinct, human-understandable action. Less is often more here.
That's a huge takeaway. Fewer, sharper tools are better than a massive toolbox.
Okay, so once you've got these well-defined tools, how do you manage how the agent actually uses them? How do you orchestrate the sequence of actions?
Right, orchestration. Again, my advice here is generally keep it simple where you can. You can achieve a huge amount of really great work using standard, predictable workflow patterns. If a task naturally fits into a single chain, tool A, then tool B, then tool C, just do that.
Makes sense. Easier to track.
Exactly. It's easier to measure, it keeps costs down generally, and it tends to be more reliable because there are fewer decision points for the LLM. You can also introduce branching logic, where the LLM makes a choice between a few paths, like in a decision tree structure.
Okay.
We use this in cybersecurity, for instance. Maybe the LLM decides if an incident is high or low severity, and that dictates the next step. Or it does multi-hop enrichment, choosing which data source to query next based on previous results.
So controlled choices. Controlled choices, exactly. Moving to a full, like highly agentic pattern where the model is just repeatedly deciding the very next action from a large set of tools over and over, that's actually much harder to measure effectively and harder to get to full performance reliably.
Right. More can go wrong.
More can go wrong. However, there's a sort of bitter lesson here, as some call it. If your chains or your decision trees become so complex, so convoluted with so many branches and conditions that they become a nightmare to maintain,
Uh-oh.
that might actually be the signal that you should consider moving to a more flexible agentic pattern. It might be easier to maintain long-term, possibly with some fine-tuning involved.
Ah, okay. So complexity becomes its own reason to embrace more agency, paradoxically.
Sometimes, yeah, for maintainability.
That's a great principle. Now, what about fixed rules? Like business logic that has to be followed precisely? Deterministic stuff? Do you just, I don't know, try and bake that into the LLM's prompt and hope for the best?
Oh, absolutely not. I would strongly advise against relying on the large language model itself to reliably apply fixed deterministic business logic.
Okay, why not?
They're just not built for that kind of guaranteed precision. They can hallucinate, they can misinterpret nuances. It's risky.
So what's the alternative?
Instead, expose tools to the agent that let it update states or trigger actions. But you build the hard logic outside the LLM. So the tool itself might have validation, sanitization checks. You maintain the critical state externally. The agent might propose an action, but your external logic verifies if the conditions are actually met before allowing it.
Got it. Keep the strict rules in traditional code, essentially, and let the agent interact with that code via tools.
Precisely. Keep your deterministic logic deterministic. Don't outsource it to the LLM.
That makes perfect sense for control and reliability. Okay, now, moving up a level. Single agents are powerful, but then you hear about multi-agent systems. What's the most compelling reason to break down a task that could be done by one agent into a system with multiple agents working together?
Yeah, multi-agent systems are getting a lot of buzz. I think the best reason, the most practical one right now, goes back to that tool collision problem we discussed.
Ah, the semantic collision issue.
Exactly. If you have a really broad domain with hundreds of potential tools, trying to shove all of those into one agent's context window is just going to kill performance.
Right. Too much confusion.
So a better approach is often to break down those large groups of tools into smaller, semantically similar clusters. Then you register each cluster with its own dedicated agent. Agent A handles user management tools. Agent B handles data analysis tools. Agent C handles communication tools, something like that.
Okay, specialized agents.
Specialized agents. And then you typically have a coordinator or router agent out front. Its job is to look at the incoming task and decide which specialized agent is best suited to handle it, or maybe sequence calls between them.
That allows you to scale much better.
It allows you to scale significantly. Yeah. You can handle a much wider variety of scenarios without overwhelming any single agent. There's also, a lot of interesting talk about the agent-to-agent protocol. That's kind of the next frontier.
What's the idea there?
Well, most successful multi-agent systems today are built by, a single team. They design the coordinator and the specialist together. The agent-to-agent protocol aims for a future where agents built by different teams, maybe even different companies, could discover each other, coordinate, and collaborate on tasks.
Wow, okay. That's ambitious.
Very ambitious.
Yeah.
It's still early days, though. Lots of technical hurdles, security questions, standardization issues to work through before that's a widespread reality, but definitely an exciting direction.
Definitely something to watch. Okay, so we've talked about building these things, tools, orchestration, maybe multiple agents. But once you've built them, how do you actually know if they're working well? If they're effective? Why is evaluation so critical here? It feels different somehow than testing normal software.
It is different, and evaluation is absolutely crucial. My sort of general recommendation, honestly, for my own team and for almost anyone I talk to in this space is invest more in evaluation than you probably think you need to.
More than you think.
Yeah, because it's become, relatively speaking, incredibly easy to slap together an agent using frameworks like LangChain or semantic kernel, hook up some tools, and get something that seems to work. Maybe hitting 70%, even 80% accuracy on initial tests pretty quickly.
Okay.
But then you hit these critical questions. How many agents should I use? How many tools per agent? Which foundation model is actually best for my specific task? What kind of memory works best? Answering those kinds of hyperparameter tuning questions is almost impossible without a really high-quality, rigorous, representative evaluation set.
Right, you need data to make those choices.
You need data. It's really pushing us towards a kind of test-driven development, but for agents, where you define your agent not just by its code, but by its expected inputs, and crucially, its desired outputs on a diverse set of test cases.
And it sounds like the whole idea of labeling data changes quite a bit in this context, too. It's not just like sending data off to be tagged anymore, is it?
That's exactly right. The term labeling used to make us think of, Amazon Mechanical Turk or outsourced tasks where people click on images.
Yeah.
But for AI architects and engineers who are actually building these agents, you really need to own that process now. You need to take responsibility for defining precisely what inputs your agent should handle and what the corresponding correct output or sequence of actions should look like.
So the builders become the labelers, in a way.
In a very real way, spending quality time defining those input-output pairs, building that evaluation set up front, it can dramatically accelerate your team later on. Especially because the ground is constantly shifting under our feet, right? New models, new frameworks, new techniques appear all the time. A solid evil set is your anchor.
Okay, so what does that evaluation look like in practice?
Typically, it involves taking real user inputs, or perhaps synthetically generated ones, running them through your agent system to get outputs. Then, crucially, performing some kind of human review or automated check on those outputs to see if they're correct or safe or effective. The results of that review, the successes, the failures, the corrections, get added back into your growing evaluation data set. Then you run that whole updated set through your agent again, maybe overnight or as part of CI/CD. You analyze the failures, often using techniques like clustering or summarization, maybe even using another LLM to help find patterns in the failures.
Ah, interesting. Using AI to debug AI.
Exactly. And then based on that analysis, you suggest improvements.
Hmm.
Maybe tweak the prompt, refine a tool description, adjust the orchestration logic, or even identify cases where you need more specific fine-tuning.
Are there tools emerging to help with this whole process?
Oh, absolutely. The ecosystem is growing fast. There are tools like Intel Agent, which is great for generating synthetic inputs to test edge cases. Microsoft has a tool called Pirate, which is specifically designed for red teaming, trying to find vulnerabilities, jailbreaks, potential compromises before you ship. Really important for safety.
Okay.
Then for actually building and managing the evaluation data sets themselves, Label Studio is a popular open source option. And then there's this whole category of automatic prompt optimization or prompt engineering tools, things like Trace, Textra, DSPy. These often use other foundation models as judges to evaluate the output of your agent and suggest specific changes to prompts or configurations to improve performance automatically.
Wow. So the tools are getting pretty sophisticated.
They are. It's all about moving away from, development by anecdote where you just fix the bugs you happen to notice towards more systematic aggregate analysis that helps you take more intelligent steps forward.
That makes a lot of sense. It's a much more rigorous approach. But what about after deployment? It feels like an iceberg, right? You see the successes, but what's happening beneath the surface? How do you get visibility into failures when it's running at scale in production?
The iceberg metaphor is perfect. It really is.
Sure.
Because these generative models, they're so good at creating plausible sounding output, even when it's wrong or subtly flawed.
Right. It can look right, but be wrong.
Exactly. And that creates a huge challenge for evaluating systems comprehensively, especially at scale. Once it's deployed, understanding the full spectrum of failures, the different ways it can go off the rails, becomes incredibly difficult just from spot checks.
So what's the solution? How do you get that visibility?
This is where observability tooling becomes absolutely critical. I strongly recommend using frameworks like OpenTelemetry.
OpenTelemetry.
Yeah, it's an open standard for collecting telemetry data logs, metrics, traces from your applications. And there are great integrations for agent frameworks. You absolutely want detailed logs of the agent's reasoning process, the tool calls it makes, the responses it gets. You want tracing to see the entire flow of a request through your system.
Okay.
And ideally, you want some form of automated clustering or summarization applied to your production logs, focusing on the failure modes. This helps you see patterns. 10% of our failures seem to be related to this specific tool failing, or there's a cluster of errors when users ask about X. That kind of insight makes it much, much easier to prioritize optimizations and improvements for the system running live.
So bringing all these threads together then, based on everything we've discussed, what are the biggest mistakes, the most common pitfalls people should try to avoid when they start building AI agents? What are you seeing out there, both internally and maybe externally too?
Yeah, we definitely see some recurring patterns. I'd say the top ones are, first and probably foremost, insufficient evaluation. Just not investing enough time and resources into building those robust test sets and that continuous evaluation loop.
Yeah.
That's honestly the biggest limitation and challenge I see holding teams back.
Okay, evaluation is number one.
Number one by a mile. Second, tool side issues. This covers a few things. Maybe not building enough of the right tools so the agent lacks capability. Or conversely, building tools but having inaccurate or unclear descriptions so the agent doesn't know how to use them properly. And that semantic overlap problem we talked about, too many tools that do similar things, leading to confusion and just worse outcomes.
Right, the tool design itself.
Exactly. Third, I'd say excessive complexity. It's so easy to get caught up chasing the latest cool technique, adding more agents, more layers, more bells and whistles.
Shiny object syndrome.
Totally. I really encourage teams to stay focused on the core principles. Only add complexity if you can clearly demonstrate it improves the actual user experience or solves a real problem. Don't add complexity for complexity's sake.
Keep simple, stupid. KISS principle applies here too.
It really does. And finally, maybe related to evaluation, is just a lack of learning, or rather difficulty in tightening that learning loop. It can be challenging to sift through all the observability data, all the evaluation results, get down to the true root causes of failures, and then figure out the most effective improvements to make. Closing that loop efficiently is hard.
Those are some really crucial pitfalls to watch out for. Now, coming from your background in cybersecurity, I know there's another layer here. This idea that agentic systems, because they can act on their own to some extent, represent a whole new class of potential vulnerability. What should listeners be thinking about regarding safety and trust?
That's a huge and incredibly important point. Designing for safety needs to be baked in at every single layer of the stack. It can't be an
All right, from the
afterthought
start.
right from the start. Tools like Pirate, the red teaming tool I mentioned, can help find vulnerabilities before deployment. But it goes beyond just running a tool. Good, solid software engineering practices are critical. Input validation, sanitization, principle of least privilege for tools, all that standard security hygiene is even more important when the system has some level of agency. And you really need to think about building in tripwires and detectors at different stages.
Tripwires.
Yeah, mechanisms that can detect if the agent seems to be going off track, maybe generating harmful content, getting stuck in a loop, or attempting actions it shouldn't. And when those tripwires are triggered, you need mechanisms for safe ejection, stopping the agentic process, and maybe falling back to a human review, especially in high-stakes or critical cases.
So building in safeguards and fallback mechanisms.
Absolutely. It's not just about making it work, it's about making it work safely and responsibly. That has to be paramount.
Wow. What an incredibly insightful deep dive. Seriously, we've covered so much ground here, from just defining what AI agents even are, to the nitty-gritty of core components like tools and orchestration, navigating those tricky advanced patterns, the absolute necessity of evaluation and observability. And finally, tackling the pitfalls and that crucial safety aspect. It's crystal clear that building effective, safe AI agents isn't just about grabbing the latest, most powerful model. It's really about thoughtful design, rigorous, continuous evaluation, and a real commitment to learning and adapting.
Absolutely. It's a whole new design paradigm, really. And maybe to leave you with a thought, I'll share a quote from the economist Paul Krugman that I think kind of captures the potential here. He said, "Productivity isn't everything, but in the long run, it is almost everything. A country's ability to prove its standards of living over time depends almost entirely on its ability to raise its output per worker."
Productivity is almost everything.
Yeah, it's a powerful statement.
And if we connect that back to what we've been talking about, this new design pattern, as you called it, for building with agents, it feels like it's fundamentally about enabling you listening, to accomplish more. It signals a potential upshift in individual and collective productivity. So maybe the final thought for you to consider is this. How could embracing these principles we've discussed, thoughtful tool design, clear orchestration, rigorous evaluation, safety-first thinking, how could that not only boost your own productivity, but maybe even start to redefine what's possible in your specific field or industry, something to really mull over?